Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.
So my name is Anna-Katrina Shedletsky. I'm CEO and one of the two founders of Instrumental. I'm going to start with a little bit of a story. So Abhinav mentioned that I spent a lot of time in China as a product design engineer at Apple. I actually worked on a line that looked very similar to this, might have even been this line, in a factory outside of Shanghai. And 6 years ago, literally 6 years ago today, I was on a line like this. And we were working on PVT for the first generation Apple Watch. So we'd launched it, but it wasn't available to ship yet. And I was here with a team of folks. We were trying to find and fix the last little bits of issues to get ready for ramp. And what I realized while standing on this line, I'd previously worked on several programs at Apple. And while the particularities of each of those individual programs and the challenges we had were different, I realized that actually the problem we were solving was always the same. It's too hard to find and fix issues in electronics manufacturing. And this leads to wasted money, time, and materials. And frankly, schedules have gotten shorter. When I first started, we had much longer schedules and much smaller teams. But now schedules are shorter, products are more complex, teams are larger to bring these products to market. And so it's gotten worse finding and fixing issues. And this year, it actually broke. In 2020, brittle, just-in-time supply chains snapped, planes were grounded, engineers like me who had jetted back and forth across the Pacific to factories around the world to actually go and work in the factories to find and fix those issues in person, try to be in the right place at the right time, weren't able to do that. And we realized that that travel itself had been a massive band-aid to a core underlying issue, which is that manufacturing is stubbornly analog. It doesn't plug in. So in 2020, companies woke up. In the last 10 months, they've rapidly adopted technologies that have not only changed how they've been able to operate in 2020, but have actually made changes in how they operate in general. And those companies are able to push forward through this challenging time and will be in a really great position for what's next. those who are lagging in adopting these technologies won't be. And so that's what today is about, is to share those learnings amongst this community so that we can all move forward together. In order to understand where we're going, we have to acknowledge where we come from in this challenge of finding and fixing issues in electronics manufacturing. So I want to talk a little bit about classical manufacturing optimization. What is it? It's a concept that's been around for a long time. You can find it in textbooks from the 80s. It's really simple in its idea. You look at the inputs to a particular process. The process this is an engineering process. So it's wherever you draw your dotted box. So it could be one operation. It could be a section of a line, a sub-assembly, the whole line, a whole factory, the whole supply chain. It's wherever you draw your box. And so we're looking at the inputs to that process and the outputs from the process. What was the performance coming out? And if we do analysis, we're able to actually figure out what do we need to change about the inputs to get the outputs that we want. And that gives us an idea of how we can take an action and actually implement that. That is the core basic loop of manufacturing optimization. Problem with this loop is that there's kind of two ways in which companies interact with it. One is they'll often do a huge effort optimization where they bring in a big 3 consulting firm. That firm spends months going and learning about everything to find efficiency improvements and have huge impact on those organizations. The other way is through bit-by-bit continuous improvement operations that are happening on factory floors everywhere, where there's individual operations managers who are making those changes as part of either Kaizen or general continuous improvement. And so in both cases, the effort is large, and it takes a while to add up all the gains to get big impact. And so it's really slow. And so as a result, in electronics manufacturing, where we can go from the first day of EVT to end of life within even a 12-month span, maybe 18 months, it's fast. And so we don't have time to do manufacturing optimization in this slow classical way. And so generally we're not. One of the places where you'll see organizations today using pieces of this is actually in failure analysis. In modern manufacturing optimization, we really want big impact with small effort. And this is a place where we can get some impact with small effort. And so the problem with failure analysis is that it's unit level. It's like one unit or a small group of units. And we're figuring out what the inputs and the outputs are for that particular small group. We're doing corrective action, and then we're closing the loop. But it's really just one loop. It's one variable, one thing. In order to get order of magnitude results, we have to think bigger than one unit at a time. What variables will drive an entire population of performance? And that's what modern manufacturing optimization is about. It's about scale. It's about understanding those variables, that multiple variables working on multiple loops to close at the same time. And if you work through those relationships, you can actually figure out how to shift and tighten the variability in your population to get better stability. So kind of two tangible examples. One might be if you're building a waterproof product, there's a whole bunch of ways in which water can get into that product. Lots of surfaces that could get contaminated, lots of areas to keep an eye on. That would be an example of a way in which you could use modern manufacturing optimization to actually get better performance at population scale. Another might be for a Wi-Fi antenna that's on a flex, and that position of that antenna is really going to drive the ultimate performance of a particular unit. And if you're able to understand and tune that geometry, exactly where it is, move it a little to the left or a little to the right, then you can actually raise all boats in the performance across the population, which will improve overall yield and maybe tighten the variability that you're seeing. So that's what I mean by multiple loops. There's more variables than just one that you're trying to optimize at the same time. And that's really where there is an opportunity today. And I think for companies that get good at this today, there's a further opportunity in what's next around doing this intergenerationally. So if you understand what the core drivers were for a particular type of product, like phones, and you build lots of phones, or laptops, and you build lots of laptops, or another device, then you can actually use those levers from generation to generation of that product line, or even between product lines, enabling your company to actually build a competitive advantage so that you can bring that type of product to market faster than anyone else, because you have a much deeper understanding of the variables that drive that production performance. So modern manufacturing optimization enables you to close every loop, whether it's at the unit level in failure analysis, the population level, or intergenerationally. And I think a lot of us here would say, this sounds great. Let's do it. But who owns doing it? When we talk to leaders, and I've talked to hundreds of leaders at this point, engineering and operations side, they tend to think that because it has the word manufacturing in it, it has to do with manufacturing process, that this is something that should be owned by the manufacturers themselves. The problem is your manufacturing partners, while very important allies in this process, they can't do this. They are one link in a chain or one piece in a thread that you are pulling together as the brand who's responsible for the product and owns this supply chain. So each of these individual suppliers may not be collecting the data that you need to be able to understand inputs and outputs, and they may have slightly different incentives around that data. And so essentially, you can't rely on any one supplier to be able to do this. The only ones who can really tie all the pieces of the thread together are the brands. And so that's where manufacturing optimization lives. So who inside the brand then is responsible for doing manufacturing optimization, for creating this vision and owning that process? Well, many people might think, well, we have like an innovation team, maybe the CTO, maybe the CIO. This is a broad scale supply chain level thing. It seems like someone at the top should probably be responsible for that vision. And for sure, there are definitely people at the top thinking about this vision, but they can't own it. And the reason they can't own it is because they don't own the outcome of the actual devices, the actual processes on the line. The only ones who really own the outcome are the engineering and operational leaders, the manufacturing leaders as a brand who own these products and make decisions about what's in the product, how it's built, what vendors are going to be used, what the specifications are, all of these micro decisions that are made. That's true ownership by these leaders. The office of the CTO doesn't know how to build great products. You do as the engineering and manufacturing leaders. And as kind of an example of this, Dimensional Research actually commissioned a study in 2020 around the number of NPI programs that were canceled in 2020. So obviously an exceptional year. I wonder what you think it might be. What percentage? 53% of programs were delayed or canceled in 2020 for NPI. At Instrumental, 100% of our customers shipped in 2020. And our customers, they're not CIOs and CTOs, although we'd love to talk to them too. They're engineering and manufacturing leaders inside these organizations. They are the ones that are owning the outcomes and making the choices that enable them to deliver. And the leaders who are doing this are getting great results. They are over-delivering on their KPIs. They're able to get to market on time or faster. They're starting with higher yields. They have better product margins than were expected, and they still have happy customers. So if you're a leader sitting here wondering, okay, I'm responsible for this, sounds a little hard. We've got complex supply chains. Closing all these loops sounds like it's going to be hard because we're moving from problem solving at the scale of a small group of units in failure analysis to many, to a population. We've talked to hundreds of teams that work across the ecosystem in fast lifecycle products, slower lifecycle products, mission critical, consumer grade, all of that. And the ones who do this process best follow a simple framework, which is they collect data from their process. They need those inputs and outputs. They do some transformations on that data. We'll talk about what some of those transformations are, but they make it useful. They find ways to present that data because manufacturing doesn't happen in a silo. There's a lot of people involved. And then they take action and are able to validate their actions. So this framework is the manufacturing optimization framework, how these companies actually operate. So to collect data, they're grabbing data from whatever the data is that matters to actually make engineering decisions from wherever it is. So sometimes they're thumb driving it off stations. Hopefully they're not, but sometimes they are. Sometimes they're taking video streams of how operators are moving or pulling off of machines or other sensors on the line. And the core piece is not just to have a whole bunch of data everywhere, it's to have it in one accessible place, because then you can actually do something with the data, and to have it in a clean, consistent format. so that when you go to transform it, you can actually make it useful. So I promised we'd talk about transformations. There's some really simple ones. Some of the basic ones would be run charts, performance over time. Some others, maybe more complex, would be statistical process control. So like understanding if your population is in control or not. And then there's some advanced transformations, such as using machine learning or AI or proprietary algorithms, perhaps to identify anomalies or potentially make recommendations. Then, because manufacturing is a complex thing, and there's not one person that can do essentially something from end to end, there's a lot of people to get on board. You need to be able to present your useful insight to others. And that means the folks in the factories, they need to know what to do, what to change. There's your engineers, and usually it's an engineer who's driving this process, but there's all their peers. There's the other teams involved, quality, reliability, et cetera. And then there's the leadership, which needs to understand, is the risk level going up, down, how are we tracking? And so this presentation of data is really important. And actually engineers like me used to spend a lot of time making keynotes to present that kind of information. And then act. So they need to make something happen on a time scale that's relevant, ideally fast. And then they want to validate that actually the change they made did the fix that they expected. And so this process seems pretty involved. And frankly, it should not feel that foreign. It's very similar to kind of the failure analysis loop. But because it's so involved, some technology would be really helpful. And in digital spaces, they have tools called like business intelligence tools. Here's an example of one looking at a bunch of servers. And this makes sense to use a presentation-based tool like this in a digital space, because if you find something that's wrong, you can just go and dial in somewhere else into the actual server itself to get the raw information and be able to take action. It doesn't work in manufacturing like that because we have physical, or I guess hybrid situations where we're not all analog or all digital, we're kind of both. And so this presentation heavy kind of business intelligence doesn't meet the unique needs of the manufacturing space. So we need our own tools. We kind of want the impact of those big one-time audits that are very expensive, but ideally combined with the speed of real-time tools that are able to automatically ingest data, like the BI tools, and to support that collect, transform, present, act framework that the best in class do for manufacturing optimization. And so when you have all these pieces, you have a manufacturing optimization system. And because I think it's important to differentiate in the ecosystem between those systems themselves and what supports them, they themselves are often supported by a critical foundation of inputs to that system. So things like MES or other places where data is coming from, sensors, inspection equipment, simulation, and then also the infrastructure that you use to run those systems. So like cloud, often if you want real time, it's got to be in the cloud, or compute, whether that's at the edge or in a centralized location. So manufacturing optimization systems are not just for electronics manufacturing. This is a concept that exists across all fields of manufacturing. And there's lots of different kinds of versions of them based on the types of data that are used and in the end result they're looking for. So in a process-driven industry like chemical or paint manufacturing, they might be looking at inputs from machine data and outputs being chemical analysis like FTIR. If you're a furniture maker, you might be watching video of an operator actually doing that assembly, and you might be looking at QC reports on the other side. In electronics, we're pulling data from sensors on the line, cameras, other places, and then we're getting outputs from the functional test data itself or reliability tests. So that's kind of an example of a couple different kinds of manufacturing optimization systems, which are pretty broad in the manufacturing space. So this room is full of practical people, manufacturing folks generally are, and today is really about tactics. So I want to get particularly tactical. I'd love to give an example of that framework, how it works, how it can be leveraged, and move forward quickly. And the way we're going to do that, because we build one, is we're going to give a quick customer example of how a customer is able to do that manufacturing optimization process quickly, supported by technology. This example is anonymized and has some sample data to kind of tell the story. Because we work with customers, we can't always share their information. So in this particular case, this customer has a pretty complex product, and their supply chain includes upstream suppliers, final assembly, as well as downstream returns and refurb. And they're actually taking data from their upstream suppliers, both in the form of images and functional test data, because they have a sub-assembly that has core functional features. They're then also grabbing data from final assembly, testing and pack out. And then because this is a newer generation product, they're also collecting data from the return center. They want to understand the functional performance of some key metrics to see if those have changed significantly and are driving returns, with the idea that if someone's returning it for a particular issue, like maybe the antenna seems flaky or something, they can go back and see if they need to change one of the specs somewhere else upstream. So that was the idea of what they wanted to optimize across this entire supply chain. And they're pulling that data into one accessible place. From that accessible place, engineers on that customer team, they're really busy. They don't have a ton of time to spend wading through data. So in general, they won't. And so that's where transformation is incredibly important. We need to do as much work as possible for an individual engineer so that they can come in and spend time being engineers and solving problems and not cleaning data. And so one of the things that Instrumental does is we have Discover AI that will actually look through every image that comes off the line and proactively identify, without being told where to look or what to look for, will identify potential anomalies and actually notify those engineers, like it's time to come in and look. And so in this case, we're able to notify the engineer that there's some issue. They come into the platform, they're able to see it, and they're able to dig right in to these kind of red boxes over here, which are indicative of this zero insertion force connector. Seems a little bit, sometimes it hasn't been fully closed. And they're able to dig in and start getting to that specific insight, which in this case, they're able to actually see that these units that don't have the ZIF connector closed for the camera also happen to have the camera fail and drop. So that's the insight. They then need to present that data really quickly to all the different stakeholders, which generally could take hours in terms of creating little PowerPoints and being able to present at a daily mode meeting or some other type of meeting with executives. So Instrumental tries to help with that in that we make it really easy for you to actually push information down to the factory for SOPs. For the engineering level, we're trying to help engineers prioritize where to best spend their time, what the top issues are. And then for the executives, we have one button. You can print out the report. So you don't even have to make a report. It automatically makes that report. And an executive can actually kind of watch and see if the defect rate goes down, which is the whole point of the acting part where you're closing the loop. So in this case, this is from a different customer, but this is real data where you can actually see the defect rate in this red line kind of going up and down. And then when they took action, so they made some physical change on the line to actually improve this particular defect. And then they also simultaneously set up a test to be able to understand if that action had the desired effect. And you can see that after they did that action, the failure rate went to 0. So that was a successful closing of the loop. So these actions, this one's small, but these actions add up. In development, they accelerate the maturity of the product, so you start at higher yield. In production, they save quarters and dollars on every unit. So at Instrumental, our mission is to build self-improving, self-optimizing assembly lines. We believe in embedding deeply with our customers to understand their challenges, how they think about their challenges, how they would move to solve them, and even their reactions to what we're doing. So we're continually inspired by them. This past summer, we had the opportunity to work with one of the most admired brands in the world who builds mission-critical quality products in the electronic space. So not consumer-grade electronics. In their industry, everything absolutely must work in the field. And they build these products over the time scale of years. So like they'll build product and they have time to actually do the classical manufacturing optimization. And we were able to work with them as they onboarded Instrumental to their process and see how they took an initial tool like ours and essentially pushed the envelope and ran 10 steps ahead in terms of how you could leverage this kind of data, and really inspired us to build this product that I'm going to announce today that we'll be shipping later this quarter. So in their particular case, they were trying to track down a yield issue that had been plaguing them for a really long time. So they weren't shipping those defects into the field because it's mission critical quality. They're able to screen them out, but it creates a lot of cost to have that yield issue. And there's about 20 different variables that they're trying to figure out causal relationships between those different values. It was not simple. It was a population scale problem. And the way they approached that problem was to gather a lot of data. They used Instrumental to do that. And then they actually started hacking Instrumental's tool to support some of those later stages of the manufacturing optimization process, a new transformation, essentially, which inspired us to build Discover relationships. So what this tool does is it's trying to help our customers connect the relationships of one set of failures to some other set of failures so that you could maybe use that for root cause analysis. So in this example, we're looking at microphone frequency response, and an engineer can quickly identify by hovering over these different tests that actually this particular point in the frequency response curve has a lot of outliers, as you can see here in red. And so they can click on this, and what you'd really want is essentially select that population of outliers and have an AI or somebody tell you, what is the same about these that have failed versus these that are passing? And so that's what Discover AI does. We're able to actually sort for our customers the potential most highly related other anomaly in the data set, which in this case, for this microphone frequency response of low signal, all 5 of the top 5 happen to be defects for contamination in the mic port. And so it's kind of pulling this right up to the top for engineers to see. And so in terms of how this could also work for LED brightness, which is could be another issue that you encounter. Here there's the outliers. What could make an LED not have the right brightness? So another example here, it's kind of identifying in this area, and you can see that it's actually this light gasket around the LED could affect the LED brightness. And so this tool is going to be really impactful for our engineer users who use the product and are trying to do these transformations to get unique insights about what's actually causing the defects they're seeing at the end of the line. We're inspired every day by leaders who are thinking strategically about their approach to optimization, which is why we value so deeply our relationships with our customers to be able to learn about how they would do this so we can build features like this. It might not feel like it for those of you who haven't been in your factory for months, if not a year at this point, but we're actually living in a golden age of manufacturing. Companies are rapidly changing how they're operating, particularly in the last 10 months have adopted new technologies that have actually influenced how they operate, how they execute. So how do we make sure that information doesn't get siloed and that we can keep moving together? Leaders tell us that they get most of their information around best practices in one-on-one conversations with their peers or former coworkers. But that process is too slow. We are not going to be able to continue pushing forward at the rate we need to as an industry if we're relying on one-to-one communication. So that's why we're here at Build Better today, is to break that mold, to try to get one-to-many, many-to-many. We've invited essentially the people that inspire us in the space to come and talk about how they are optimizing their process, actual tactics and tools for doing that, so that we can, as an entire community, figure out what's happening now and what's next.